Welcome to this session. It's working in 3D in the ArcGIS API for JavaScript. My name is Jesse. This is Adrian. We come from the Zurich R&D office of Esri, and we work primarily on 3D in the JS API. At least our team. There's another team working on the city engine. So in this talk, this is really a very basic talk introducing people to 3D, how you work with that. So it's going to touch all of the basics. You don't need any previous knowledge of 3D, so I don't know if that's why you're here, just interest or introduction, but this is going to be pretty basic. We're going to touch on most of the differences between doing this in 2D and in 3D, so we're going to talk about the map view and the scene view. We're going to talk about the web scene, what does it mean, how you can use that. And then we're going to talk about all the different layer types that are supported in 3D, also the ones that are in 2D and how we render them in 3D, but also the 3D specific ones. And we're going to talk a bit about the symbology. So how does symbology work in 3D? I'm going to start with some explanation about the scene view. So I don't know if you've already seen or how familiar you are with the API, but in 4X we try to make the scene view and the map view, so the 2D and the 3D side, work very, very similarly. So if you start out and you already are familiar with the 2D side, it's really, really easy to then start to work in 3D. At least that's what we wanted to do. So what I have here is a map view. So this is in 2D. I have a layer in there and I can navigate around. And the only thing really that you have to do if you have a simple setup like this is to change map view here with scene view. And so if I do that, I get basically the exact same data and the exact same visualization, except now I'm on the globe, right? So I'm in 3D now. We try to have this throughout the whole API. So how you would use it in 2D, we try to do the same thing in 3D to make this as easy as possible to transition. So what's that? So I already mentioned this a little bit. So there's a unified 2D and 3D data model. So behind this is the base class that we have for storing the layers and stuff like this is the map. And you can use the map in both the map view and the scene view. I'm going to talk a bit about what the web scene is a bit later, which is specific for 3D. We have layers, we have renderers and symbols. All of these things, they are the same. So the same layer types work in 2D and in 3D. And the same for the renderers. All the infrastructure is really the same. So we have a common view subclass between 2D and 3D, and then we have, I already showed that, we have one map view and then a scene view. And then there it's really like map view is rendering only 2D and scene view is rendering only 3D. So we try to make this really easy or boring to transition to 3D, or at least to get you started, right? So yeah, like I said before, you have your map view or your app that uses a 2D map view and you want to try out like how this works in 3D, you just change this to scene view and you get the same map in 3D. Of course, then that's the basics, but if you then want to actually exploit like the 3D parts of the scene, you also need to understand certain 3D concepts. So you cannot just stay with all the 2D conceptions. So I'm going to talk a little bit about what that means and what kind of things you need to know. This is the basic interface of the scene view. You can also find all the stuff on the SDK if you have not looked at this yet, but I will just briefly go into the most important parts. So we have the camera. This is the 3D equivalent of the view specification. So where you would use maybe extend or center and scale, we have a camera. I will talk a bit about this. We'll have GoTo. This is also the same as in 2D. This works on the map view as well, which is our way to really quickly go to a certain location. I'll also show examples of this. We have a set of constraints. There are also constraints in 2D, but we have different ones. I'll not go into details here, but you can look this up in the SDK. Padding, exactly the same as in 2D. And converting coordinate systems, so toScreen to map. This also you have it on the scene view, on the map view. And I will show a bit like what are the differences and how does this work. So looking at the camera, this is really the camera is important because it's the primary specification of the view. So we have a camera that has a position, which is basically where the camera is located in 3D space. So it has X, Y, Z. X and Y are in the spatial reference of the view, and then Z is elevation in meters. And then there's a heading and a tilt. So this defines like the viewing angle, let's say, of the camera. So just to show you a very simple and little example of how this works. So I made a little example where I want to rotate the camera like around the position and just increase the heading. And then when I play this, you can see that I'm basically, like the camera stays in the same 3D position, right? But then I'm looking around the scene. So that's the basic camera, right? And then this is tilt, right? And so heading and then position is when I move around like this. So you can work directly with the camera, but often if you just want to change like heading or tilt, this is kind of simple, or just the position. But if you actually want to, let's say, view a certain graphic or go to a certain location, maybe view like a whole extent of a layer, this is not really convenient. You would have to do a lot of computation. And so we have this method called GoTo. And GoTo has a lot of different parameters. You can go to a set of graphics, like I said, an extent, so geometries. You can set the heading, scale, tilt, all these kind of things. And it's very convenient. So you can look also at the SDK. I have a talk later today that is about all the like camera control. So if you're interested in that, you can also go to this. So here I have a small example. Basically, I use GoTo and I increase the heading to always go to a multiple of 30 degrees. And then so if I play this, you can see that it's basically changing the heading. Now, the difference with this from before is, as you can see, I'm actually rotating around the center of the view here. And we do this because we try to preserve all the other properties of the scene view, such as center, tilt, and stuff like this. So it's primarily preserving the view and not necessarily the camera properties. As you can see, it also animates. So that's by default. You can turn this off as well. And so to show a little bit, so we added a couple new animation options since 4.2 that you can use to actually control better the kind of animations that you do. So we used to not have any options. You couldn't control these animations. But now we have a few additional ones. I'll just show two here, which are easing. So we have a couple of built-in easing functions. These are like the standard easing functions that you might know from other JS frameworks. And we can also easily increase or decrease the speed. So here, I basically, this is now snapping to 120 degrees to make it a bit more obvious, like how the animation works. And you can see that the animation is slower, and it kind of like has this easing out cubic function to do the easing. Again, you can look at the SDK. Also, there's some samples and other like easing options, and there's a couple of other things that you can do. The padding, I like to show this because there's some things specific in 3D about how the padding works, but in general, we try to have the exact same behavior as in 2D. So padding on the view, if you've not tried that, so I just played the snippet, is where you can have some UI that overlays on your scene, basically, or on your map, and then the interaction should actually happen in this visible area here. And so basically, what you see now is that, for example, if I rotate, I don't rotate around the center of my like full screen, but around the center of this where it's basically not padded. And it's for all the interaction like this. So if I zoom out, which we do from the center of the view, it also zooms out from this point. So this can be quite useful if you build your own app and you want to put some UI on the side or on the top, but you still want to kind of see the map, let's say the view through your UI, this kind of screen door effect, then you can use this. Here I also show a little mini map. Actually, this is a 2D map view that is on the same location as the 3D view. So these kind of things are also quite easy to do. The other thing that I want to talk about a bit is these toMap, toScreen, and hitTest functions. And I just want to show a little example of how this works. So toMap and toScreen can be used to convert between map coordinates and screen coordinates. So let's say if I click here in the screen, I get an XY pixel position, and then I convert it to a map point, and I get, so in the spatial reference of the view, I will get the spatial coordinates of that. And the other way around, if I have a map point and I want to know where on the screen pixel position it is, so I can maybe put like some UI on that location, then I can use toScreen. Finally, hitTest, I can use that to, if you have a screen point and you want to find a certain graphic in your scene, you can use hitTest with the screen coordinates and it will give you back a graphic. So here I have a small snippet. Basically, if I play this, it will go through these two loops, so it will do this 4 times, and we'll add some new graphics to the view. And here it's using, basically what I'm going to do is take the screen, and then at like quarters of the screen, I'm going to put the graphics. So I'll just take, like these are pixel positions, and I'll use view.tomap to convert these into map points, and then place the graphics. So these are just simple spheres. You can see that I placed them here in screen space, basically, at these coordinates, and then they are in the map. The other thing that I have down here is, this is something that we also newly introduced. This is our new input system, where we have unified eventing for interactive input. And this is we can use the pointer move event here, and then use a hitTest on the view. So we get XY each time the mouse moves over the map. Do a hitTest on that point and get a result back. And then if there is a graphic under it, I'm gonna display it here in this black box. I added some attributes here, the XY indices that I used, and then I will show them here. So as I move the mouse over the screen, you can see that as soon as I hit one of these graphics, you get basically this information out. And you can use this in various ways. So that's a bit about the really all the basic stuff of the SceneView. Again, if you want to know more, go to the SDK. There are samples and all the properties are explained there. Now I would like to talk a bit more about the web scene. So the web scene, it's basically like the map, right? The map is a base class of the web scene, and the web scene inherits things like operational layers and a couple of other things from the map, but then adds a couple of new things on top as well that are specifically for working in 3D. So it defines the content and the style of the 3D scene. The web scene is really the same as the web map for 2D, but for 3D. So the web scene is serialized as JSON, just as the web map, and it's stored in Portal and online as Portal items. What is a bit more recent is the WebScene specification. We had it always internally, but we're also now publishing it online for you to look at. It's really similar to the web map spec if you're already familiar with that. So we have the layers, we have the base map, but there's also some other things that we do differently. For example, we have a presentation with slides. I will show also an example of this. There's an initial state which has some so the initial camera position, for example, we have the environment, lighting settings, things like that. And then there's also metadata in the web scene. So the type of scene, I will also show you the different types of scenes that we support, the spatial reference, the version of the scene spec that we wrote out, and things like the application that authored it, this kind of stuff. And if you want, so there's this, it's the same basic location as the web map specification, if you know it. So if you type map here, then it goes there. And you can look at this. This is very recent, and we also would like to have feedback on that. So if you're interested in this, maybe you can have a look at that, go over it, check a bit out, like how the whole web scene basically document is stored. So in terms of the API, The web scene is only supported by the scene view, right? You cannot use a web scene with a map view. That doesn't work. It's really a subclass of the map. So I'll show that here in this little snippet that defines kind of the interface of the web scene. And it's loadable from Portal. And I'll show also how this works. So basically, we get the properties from the map, like the operational layers, and we add on top certain things like presentation and slides, initial view properties, the things that I mentioned. We have the Portal item to load and save things from Portal. And there's a bunch of other things that I will not go into, but you can also have a look at things like clipping area, which works in certain scene types where you can basically reduce the extent of what you want to look at. So the web scene is similar to the web map. It's really a platform thing. So it's not just the JS API that works with this. It's all the other clients. So it's the scene viewer that you find on ArcGIS Online or in Portal. It's Pro. It's the templates, the web app builder, the story maps, all the API and SDKs like runtime. They read and write these things. So it's really the central storage of the platform for 3D scenes. So just to show some examples of how this works and how you can work with it, and these are really easy to build now. So this didn't used to be like that. For example, in 3x, as I'm not so familiar with 3x because I work only on 4x, but as far as I know, it's much harder to do these things. So what I have here is that I have this scene that is actually stored on ArcGIS Online in a Portal item. And basically the only thing that I need to do to load this and fully visualize it is to create a new web scene and say, okay, this is the Portal item that you should load from. I add this in the scene view as the map property here. And basically if I do this, and it's really only this in this little example that I have here, it just loads the whole scene and you can see all the data in there. And then we have a couple of widgets that work with that and then show you things like, for example, here the layer list. This is also a new widget that's currently in beta. Basically here it shows all the operational layers of this scene. One thing that we do not have yet in the API as a widget is a slides widget, but I just built a simple one here inside this little snippet. And you can see that, for example, this scene has a whole bunch of slides stored. And that's API that makes it really easy if you click on a slide to go there. So we try to make it really easy to build this kind of application that is very similar to what you would find on ArcGIS Online with only a very small amount of code. So if I click on these slides, you can see that it goes there, but it also affects things like the visibility of the layers that are stored in the slide. There's lighting, things like that. So if I go to different slides, you can see that it's visualizing different parts. Here in the layer list, I can turn off and on slides and things like that. So this is very simple to build, right? So you just give it the Portal item ID and it will load it for you, and you can work with the scene. So on to saving. Saving is a little bit more involved, but not that much more. So if I make some changes to the web scene and now I want to save it out to Portal, how does that work? So this is really the same scene. I just use the same stuff to load it back in. But now I'm going to make some changes to it and then save it out. So first, I'm going to try and remove one of these layers. Maybe I don't like this particular layer. So I'll go over the layers, find the one that has this title, 1045, so this layer here. And then I'm going to remove it from the scene. And now it's gone, basically. So this was really easy, right? So you just remove the layer and the widget automatically updates. This is all done for you. Similarly, like the slides widget here, if I would remove a slide, it would also, or add one, it would also update. So that's what I wanted to show next, is how you create a new slide and then add it to the scene. So we have an API which is called slide.createFrom. This is a static method on slide, and you give it the view, and it will create a slide that's kind of a snapshot of the current view. So let's try to, let's say I want to maybe just have this base map here and maybe zoom out a little bit to have a nice initial view. And then I'm gonna create the slide. So createFrom will return a promise because it's an asynchronous operation. This is because it needs to do some things like create a screenshot and stuff like that of the scene. So that's why I have to wait for it to complete, and then I get the slide. I can set a title on it. There's a bunch of other things that you can set on the slide and metadata, and then I'll add it to the presentation. So once I've done that, I can see, okay, I have a new slide here in my slide deck. If I change again and I click, you can see how it restores, basically stores the state of the view. So now I made some changes and I want to save them back out. So how does that work? There's basically two API-like methods that you should know about when you want to do this. The first is to update the scene from the current view. We do this because the scene itself stores things like the initial camera, the lighting, stuff like this. And so if you don't want to make any changes, that's fine, you don't need to do this. But as soon as I want to say, okay, if you load the scene, I want to see this as my initial view, I will use update from, it will store that in the scene, and then I can save it. And saving it itself is very simple. You just say scene.saveAs, or if you want to override the same one, you use scene.save. You can give it a certain metadata again. For example, I'll have here the title, and I give it the portal where I want to save it to. So if I do this, it will first ask me to sign in. I'm not currently signed in here, so I will quickly do that. And what I did here is now, as soon as it saves it, so this goes to portal, it saves it, just for this demo, I open it in ArcGIS Online, so you can see that it's saved here. It has my demo scene title, it has all the layers inside, all this kind of things. And I can now open it, for example, in any other client and get the same result back. So here I open it in the scene viewer. I can see this is the initial view that I stored. Here is my slide that I created if I go there. So all these things are stored in the web scene. Try to go back. Yeah. A couple of other things. I won't go into too much detail. There is a viewing mode on the web scene. We have two types of viewing modes for the scene view for 3D scenes. One is the one that I showed for now, which is the global, basically just like the globe, right? So we also have a local mode, which is really a planar mode. So we don't have a sphere anymore, like an actual planet, but this is just projected on a plane. So we use local mode to have, like, if you have local data or concentrated data, you don't want to go have, like, you don't need to go everywhere on the globe. Or also we use this for projected coordinate systems. In the sphere, you can only use WebMercator or WS84. And that's we don't do any client-side reprojections. So if you want to use any other kind of projected coordinate system, then the only option you have is really local mode. You can look at these also later if you want to. They're part of the SDK. Some last things. There is the base map and the ground. I just want to quickly mention it. So we have the base map. This is really the same concept as in 2D, but we also have something called ground. And the ground defines the ground elevation surface of the scene. And the ground consists of elevation layers right now. And hopefully in the future we'll add additional surface properties that allow you to do other things, like, for example, visualization or exaggeration, things like that. For now we don't have this yet, but this is planned. And we have support for default world elevation layer as a kind of simple way to set the elevation, similar to, if you know that about the base maps, you can use a string, like a well-known name, and then we'll just give you the right layers in there. All right, I'll give it to Adrian to talk about layer types.
Okay. Yeah, hello everyone. In the next couple of minutes, I will go through various layer types, some of which you might already know from 2D, some which are introduced exclusively for 3D. and show how you visualize them in the 3D.js API. So let's first start with feature layers. Probably know them from 2D, and we fully support them as well in 3D with some additional properties on top of them. More specifically, the elevation info, which basically defines how the elevation, the C value of features in your layer is rendered in 3D. You can see this here in this example, where we have a feature layer that we load, and during loading time, we can specify the elevation info on it. For the mode, there's 3 different options: relative to ground, absolute, and on the ground. More on this later. And possibly an offset, which comes into play if you're not specifying on to ground. Now, what we have here is the relative to ground mode. In this case, for each feature, the effective elevation value in the end is a combination of the offset you specified, the C value stored in the geometry of the feature, as well as the elevation of the ground below the feature. These 3 values are added up. If we're looking at absolute height, it's very similar actually. Probably difficult to see the difference. Basically what happens here is that it's only a combination of 2 values. Again, the offset and the C value of the geometry, but the elevation of the ground below the feature is ignored. So it's basically relative to sea level in this case. Lastly, the elevation mode that is closest to 2D is on the ground, in which case the features get draped down onto the ground geometry. Okay. Now, next. A new feature that was introduced in the 4.3 API, in the 4.3 release of the API is feature editing, which in this example that you also can find on the SDK allows you, once you've loaded an item from Portal that has is editable, it allows you basically, in this example, to add new features, attributes to it, and store this data. Now, this is the UI way of accessing it as defined in this example, but for us coders, it might be interesting to see how this is done in code, which is this code snippet down here. So first, we'll quickly move the camera to a different vantage point, which happens to be Palm Springs Convention Center, where we are, and we're going to add this here using this code, and here it goes, appears, and if we look at it, it has the attributes that we specified down here when creating the graphic. Yeah, it should be noted that currently in the 4.3 release, this is only supported on an API level. Widgets and tooling for this will come in a future release. Then there's elevation layers. They're basically, well, they introduce the 3D component to your base map, to your terrain, to your ground. What we support is our only tiled image services that come in the LERC, limited error raster compression format. Now, as opposed to operational layers, which are added to the map.layers directly, elevation layers are added to map.ground.layers. We offer an API to query elevation at scene points, and this API is both supported on individual elevation layers, in which case you get the elevation from this specific layer, or generally on the ground. In this case, it behaves like layers would behave. Basically, they are overlaid, and the topmost layer that has data in your current region is sampled or queried. We can see this here, what I just talked about in this interactive example. Here we have a scenario of a landslide, and the base map, interestingly, already visualizes the after the landslide imagery. But if we look closely, we see here, for example, that the elevation layer actually doesn't match the default elevation, which we got here by specifying ground world elevation when creating a map, by the way. So what we can do is we can toggle the visibility of our additional elevation layer here, and our terrain updates and properly represents the elevation after the landslide. Lastly, what we see here is the querying that I mentioned earlier. Here, when the user or when I click on the scene, let's see, we catch this event, we get the correct map point, and query the specific elevation layer that we specified up here at this position. Once the result is ready, this is an asynchronous operation. We print it out, and this is visualized down here. So we can do this at various positions. We see as we go up here, there is increase, and down in the value, it's lower. Okay, let's continue with scene layers. Scene layers are basically the equivalent to feature layers in 2D. They support both point and mesh features. Now, one thing that I forgot to mention earlier for feature layers is that, for example, for point features, the number of features in a layer is quite restricted in 3D. I think the number is around 15,000 features. Scene layers, on the other hand, are specifically optimized for 3D and support level of detail and consequently a way higher number of features. You can see this here in this example where we load a scene layer with point features, and this data set basically visualizes airports all over the globe. I've added some custom symbology to this just to make the visualization nicer. This is not represented here in the example, but yes, I will talk about this later more specifically. What is interesting here is to see the level of detail aspect that I mentioned earlier. So as we zoom in, higher detail data is added automatically, and as we zoom out, it will be again updated interactively, adjusting the amount of features displayed. The other scene layer, or the other type of scene layer, is a mesh scene layer, where the individual, in this case, for example, the individual features are buildings in New York. Again, a really high number of features is supported. There's also level of detail happening, which will, as I zoom in here, will gradually be updated to a higher resolution. Come on. And while this is not the case in this example, these mesh features, they also support textures, so they could be textured with like facades and similar. Now, correct me if I'm wrong, but also newly introduced in this release is scene layer filtering. So again, the same data set as just before. We load the layer, add it to the map, display it, and on the scene layer we can specify these definition expressions, which are simple SQL statements, as you know them also, might know them from feature layers. So if we only want to show really old buildings from before 1900, we simply set the definition expression like this on the scene layer, and it will update to only show a very small selection of buildings in New York that were built before that year. You might have noticed that there's like this addition here. I ran into this while working on the demo. This is a small detail that some of the buildings in this data set simply don't have a construction year set, in which case the returned value would be 0, and we're filtering those out. So we can go back, display the whole thing by resetting the definition expression, setting it to null. And maybe we want to only display buildings below a certain height. Can again do this and get these displayed here. So if we look at one of the taller ones, and at the attributes defined on it, we see here that its height actually is 26, 27 feet. Yeah, I guess. Okay, let's continue. The other thing also newly introduced are scene layer queries. Here I'm using an example again from the SDK, which is actually quite involved and still loading. It also does filtering of like floors and so on, but the part we're interested in is here this legend, which displays for individual room types how many of them are currently like in the current filtered selection. And this is basically done as follows. So we filter for this building here in the office layer and then create a query on the office layer. This will basically copy the definition expression we have set already up here. We then specify which attributes we're actually interested in, and we start an asynchronous query on the office layer. Once the results are ready, we do some processing here. We basically go over all returned features and put them into bins, counting how many of each we find. Eventually, left out here, we update the legend that you see here. And if we change the selection of buildings or floors, we see that this legend, by running this code here on the left, updates. Okay, next, more on the visual and less on the interactive querying side are integrated mesh layers, which are a really cool feature to like display data, for example, captured like from Esri's drone to map. Is that right? Yeah. Basically, what we have here is very high resolution textured geometry, which is one single mesh. Again, supports level of detail, and is like properly integrated with the ground. Yeah, this is one of the more heavyweight like data sets. I think Oxford, if I'm not mistaken. So this usually takes a while to load. But if you look closely, you get really, really high resolution data in your 3D scene. And again, this is a completely interactive experience at various scales. Point cloud layers are also a very exciting feature. Again, usually captured from drone data. These allow to display a really, really large amount of point data in your scene. The rendering can be highly modified. In this case here, this is just like one of many examples, but of a simple point cloud RGB render, which takes RGB values from the actual data. But there's many more like class breaks and so on for like classification, for example, power lines below a certain height or something like that. And the cool thing here is with visualization, on this visualization, is that we can like modify the point size in screen space, or we can also, let's tune that down a little bit again, increase the density again in screen to adjust the experience basically. And as I mentioned, these datasets can get really, really large. So let's see if we zoom out here, how large this particular one is. Yeah, I think that's about where we get at. And again, yeah, automatic level of detail is provided. There's a couple more layers, mostly coming from 2D that we also support. There's like tile layer, vector tile layers. For ArcGIS cached tile services, they are supported. Web tile layers if you're going for non-ArcGIS server map tiles, in which case you'll provide a URL template. And also map image layers, aka dynamic layers, for ArcGIS map services, in which case the service will be queried on the export image REST point. And that's it from my side. Thank you very much. I'll hand over back to Jesse.
So the last topic that I want to talk about in this presentation is visualization and symbology. So I'm gonna run through. Sorry. Oh, okay. I'm gonna run through a whole bunch of samples that you can also look at later online. By the way, this presentation will obviously be made available. Also, all the code and the snippets, you can look at that later. So the visualization, it doesn't have to be, but often it's data-driven, right? So we have different types of, let's say, visualization schemes, I would say, and then we separate these a bit out into thematic kind of visualizations or location-based visualizations. And so I'm just going to go through a couple of examples of things that you can do. These are all, I'm not going to go in all the details, I will show some code, but these are all based on the concept that you already know. So these are unique value renderers or visual variables, things like that, that also work all the same way in 3D, except that you have a couple more possibilities to basically drive certain parts of the visualization with attributes. So this is a particular example. This is a pretty simple example. Here we have Hurricane Andrew data. basically visualizing them with 3D cylinders. You can see that we use color here, but also the size, like the height of the cylinder, to visualize certain attributes of this data. So let me try. I'm gonna try to go out. Let me know if this is not very visible. And I can update. Let me try it. Okay, like this. So I will talk a little bit about how the actual 3D symbology works. It works a little bit different than the 2D symbology. So maybe don't focus too much on that. But if you look here at the render, and you likely already know how this works from 2D, we basically have just some visual variables here that are addressing parts of that symbology. So here we have a visual variable that drives the height, which is the wind speed here, and we have another one, a fixed size for the width, and we also have then coloring based on the pressure. So there are certain attributes or certain properties of the symbology that you can drive that are a bit different from the 2D symbology, and one of them here is height. I will show some other ones in some other examples. Let me go back to the presentation. This one, so here I have an example of a local scene. So this scene is only here focused on Northern America, and basically showing, if I'm not incorrect, election data. And here you can see that it's easy to kind of drive the data with different types of variables, and maybe more than you can do in 2D while still preserving like information. So here we drive the color as well as the height of the cylinder, and also like the width of the cylinder to indicate certain information. Obviously pop-ups work in 3D as well. And just to give you an idea of what this looks like, so basically we just have the feature layer, there's a pop-up template to show this information. I have a scene view, and then here again I have the visual variables, and then I will drive the height of this by this field. I will drive the width and the depth of the cylinder by another. So this is our two different sizes, right, that we can drive in 3D. And then finally also we drive the color again with a field here that kind of like scales between these two colors. So these are more like the thematic kind of visualizations, but we also have something that we call location-based visualization, so more like where is it and what does it look like. And these are things like more like buildings and trees, and I will also show these examples. So this one, it's a feature layer which has basically floor plans, and then we have a symbol to extrude them, and you can also drive this with an attribute. So here we have building data that have a whole bunch of attributes. Let me try to find the right one. But basically we have a symbology specification that drives the extrusion of a polygon. And here we drive it by, this field is called elevation. I think it's just the building height really that it specifies here. And then so you can see how you can easily drive these kind of symbols that are just locations with various attributes. Let's go to a couple other examples. Trees. So this is a representation of thematic representation of trees. We have locations of where the trees are, and they have attributes like specifying what is the size of the trunk of the tree, what is the size of the canopy, so like the crown of the tree. And then we use a bunch, like two separate symbols, one to visualize the trunk, and the other one to visualize here like the width and the height, to get kind of, it's still a thematic representation, right? This is not a realistic representation, but you can drive, let's say, these location-based features with various attributes. So again, it's the same thing. So we have visual variables that drive the size by the height and the width of these symbols. And we also can then color them. In this case, it's based on carbon storage. Yeah. So you can create, you have a bit more dimensions, let's say, to convey information than in 2D that you can exploit in 3D. I will skip over this one. You can look at that one online also. I just wanted to show this one. So we can do the same. These were all feature layers, basically, even though we show maybe 3D symbology on them. But we can also do the same with scene layers. So here, okay, this I'm not going to show. Here, this is the sandbox. You can also look at this. This link from the SDK where we use a renderer to colorize these buildings. So this is again the same New York scene. And we'll just go here. So we have a visual variable here that basically maps the construction year to the color of the building. So you can see which buildings are older, like have been constructed in the past. So all the renderings that you can do on the feature layers, you can also do them on the scene layers. So now a little bit of how this works in detail. So you've already seen probably in these little code snippets like the 3D symbology. So there is the existing 2D symbology works really the same as in 3x. So we have all the same concepts there. So we have like a simple fill symbol and stuff like that. In 3D, we introduce a kind of new concept, which is more similar to how Pro also defines the symbology, where you have a symbol container and then multiple layers within that symbol that can have different visualizations. A 3D symbol must have at least one symbol layer, and this is mostly the common case where you want to just visualize a single thing, but you can also just visualize with one symbol multiple types of things. So that's an important distinction. We do support the 2D symbology, so if you have a feature service and it has some drawing info and a symbol in there that's a 2D symbol, then we do support that. But you have to know that internally we just convert this into a 3D symbol. So if there is something that is represented in a 2D symbol, but we don't have this in 3D symbology, and there's a couple, we're trying to really match like the same feature set there, but we don't support everything. So one example is picture fill symbol. We don't have that in 3D, at least not yet. So it's always good to maybe, if you're interested in this and want to know, look at the 3D symbology, what the feature set is, and then if something doesn't work because we don't know how to convert it, then you know where that comes from. So for the visualization, we kind of make a distinction between what we call flat symbology and volumetric symbology. And the flat symbology that you see here on the top is the things like the icon symbol 3D layer, the line symbol 3D layer, and the fill symbol 3D layer. And these are visualizations that are, like it says, like the representation is flat. So it's not exactly like in 2D. Unless you drape it, then it's more or less the same. But for example, for icons, if you don't drape them, we have this kind of billboarded icons in 3D. So they behave a bit differently, but they're all still flat. So they don't have any volume to them, right? They're represented, they're like located in 3D space, but they don't have themselves like a 3D visualization. The volumetric ones, basically we have like a 1-to-1 mapping. So if you have icon symbol 3D layer would be the flat version, then we have object symbol 3D layer, which is the volumetric one. And then we'll have line symbol 3D layer, which is the flat one, and path symbol 3D layer, which is the 3D version of that. You can see here in the screenshots, I'm not sure how well it comes across, but you can also look at this online. The fill symbol layer, we have the extrude symbol layer, so where you extrude, let's say, a polygon out. So the last thing that I want to mention is something that we also newly introduced that you may not be so familiar with, which is something that we call WebStyleSymbols. These are symbols that are stored in ArcGIS Online or on Portal as portal items, and there's a kind of a library of symbols that you can then reuse yourself. We, for example, expose this now in the scene viewer, where you have a symbol gallery and you can pick symbols. But we also support this fully in the API. And I just wanted to briefly show what this looks like. And here I have a small snippet, but you'll see this a bit clearer, like how you use this. It's basically referencing by name a certain item from Portal, and then you can just use it as any other symbology. I'll just show this here in this play. So we build a playground for you to kind of, I know, test out these symbols, and it's more than just the web style symbols. You can kind of try out all the other different symbols as well, and it will give you then the code to use that in the API. So it's really a kind of easy and visual way to figure out what you want and then copy and paste it to your code. So here I've selected the realistic street scene style. There's a couple of them here that you can choose from, and I chose the picnic table. I can choose another one. Let's find like trash bin 1, and you can see that it updates. So this is basically loaded from Portal, that it gets all the geometry data and then visualized as a point symbol. And here you can see, okay, so if I want to use this, I can construct it like this. I can put it in a renderer, and that works. I need to import this module first, obviously, to get that web style symbol available. And like I said, there's a whole bunch of these that you can look at. We're trying to extend this further. Where did that go? So let's, for example, ambulance. So some of these might take a little bit of time. They are quite high resolution, but once they're loaded, it's pretty fast. So things like buses and stuff like that. So yeah, you can go here. It's linked from the SDK. Maybe play around, look at the different symbols. As I mentioned, you can also use not the web style symbol, but check or test all the other symbology. Okay. All right, so that's it for this presentation. Does anybody have any questions for us? No questions? Nobody has questions? If you don't want to ask them in public, you can also just come here and ask them here, if that's easier. Yes? This right now, not yet. These are like a fixed set of web styles that we currently support, but this is planned for the future, where you can actually author your own web styles and then consume them, but it's not there yet. Yeah. All right, if there's no other questions, thank you for your attention.